Multiplying and dividing rational expressions is basically an extension of simplifying, where we're just comparing multiple fractions and using our fraction operation rules for dividing fractions in order to simplify. So when we want to find the product of these two, well, we can think of this as just x squared divided by x plus 3 times x plus 3 over x. Well, when we multiply fractions together, the numerators get multiplied and the denominators get multiplied. But when we're dealing with rational expressions, sometimes we don't actually have to do any distributive and simplify and then refactor. Just keep in mind that we have x squared times the quantity x plus 3. It's already factored. If we wanted to, we could break apart x squared into x times x to make simplifying a little bit easier. Same thing in the denominator, we have x plus 3 times x. Everything's already factored. So we can identify common factors in the numerator and the denominator. And we see that here all we're left with is just an x in the numerator. Here we have the same thing, but it's in function notation, and we're going to do division. So we have to apply our division rule of fractions. Remember that when we have to divide two fractions, what we really do is multiply the first fraction by the reciprocal of the second fraction. So we'll take our function f of x, which is x squared plus 2x plus 1, over x plus 3, and we're going to multiply it by the reciprocal of g of x, which is x squared plus 4x plus 3 over x. Now we've got some trinomials that we'll want to go ahead and factor. So here we have x plus 1 times x plus 1 over x plus 3. And our second fraction factors to be x plus 3, x plus 1 over x. And then what we want to do again is look for a common factor. And we can essentially just treat this as one big fraction now, like we did before. Because I have x plus 1, x plus 1, x plus 3, x plus 1, all over x plus 3 and x. Well, our only common factor is the x plus 3. So we are left with x plus 1 3 times all over x.